you probably look at a deck and, just see an outdoor floor.
Right, like a simple, flat place to put a barbecue.
Yeah, exactly.
Yeah.
Pull up a chair, enjoy the weekend. But right now, beneath your feet, there is this incredibly complex, heavily loaded structural system that is, well, it's actively under siege.
It really is. It's fighting a constant battle.
Welcome to the deep dive. We designed this custom deep dive specifically for you, the learner, because we know you don't just want that surface level summary.
No, you want to grasp the actual mechanics of the world around you.
Right. So today, we are extracting the ultimate cheat sheet on deck repair, structural safety, and property maintenance. And we're using the famously demanding environment of North Vancouver as our ultimate testing ground.
Which is an incredible place to study this.
It really is. We are going to uncover the invisible physics of structural failure, decode the material science of weatherproofing, and figure out how, really gentle habits can prevent catastrophic, expensive disasters.
It's all about preventative care.
So, okay, let's unpack this, because a deck truly creates an illusion of simplicity, doesn't it? We just treat it like a piece of landscaping.
We do, but from an engineering perspective, it's an elevated weight-bearing bridge attached to the side of a house. It is a brilliant example of complex engineering masking itself as leisure.
Masking itself as leisure. I like that.
Yeah, I mean, when you step out there, your brain just registers patio furniture. But underneath those floorboards is a totally dynamic system. It's load distribution, shear forces, and material science that has to perfectly balance against a relentlessly hostile outdoor environment.
So it's not just a weekend chore to keep it clean.
Oh, far beyond that.
Yeah.
What we are exploring today is far beyond a list of weekend chores. It is a masterclass in structural integrity and the compounding financial value of preventative care.
Because understanding the physics gives you an advantage.
Exactly. Understanding the physics of the system gives you a distinct advantage in protecting your property and, fundamentally, the lives of the people standing on it.
Wow. And to really understand how these structures fail, we are anchoring this conversation in North Vancouver.
Yes, the perfect baseline.
Because when you look at the environmental baseline there, it is intensely demanding. We aren't just talking about, a rainy Tuesday.
No, not at all.
We are talking about heavy, relentless precipitation, persistent moisture retention in the air and the soil, and constant seasonal temperature shifts between freezing and thawing.
It's extreme.
It makes you realize that rain isn't just water falling from the sky. It behaves more like a slow-motion, relentless stress test for every single piece of wood and metal.
That is the exact way to visualize it. It is an active, ongoing test of material endurance. The environment is constantly searching for a weak point in the armor.
But I want to push back on that idea just a little bit, or at least play devil's advocate here.
Sure, go ahead.
If a deck passes building codes, uses pressure-treated lumber, and has a proper vinyl covering, shouldn't it inherently withstand rain? I mean, humans have been building boats out of wood for thousands of years, right?
That's a fair point.
It's an outdoor structure. It's literally meant to get wet.
Well, what's fascinating here is that the structural damage isn't actually caused by water hitting the deck and rolling off. A quick rainstorm isn't the enemy.
Wait, really?
Yeah, the true destructive force is persistent dampness. North Vancouver's climate creates an environment where things often just cannot fully dry out before the next weather event rolls in.
Oh, so it just stays wet.
Exactly. So water doesn't just sit on the surface, it infiltrates on a microscopic level.
Because wood isn't like a solid block of matter, right? It's porous.
Precisely. If you look at wood under a microscope, it looks like a dense bundle of hollow straws. Those are the cellulose fibers that used to carry water up the tree.
Oh, that makes sense.
Yeah, and when a deck sits in a state of persistent dampness, those cellulose tubes wick up and retain the moisture. Now, introduce those seasonal temperature shifts you mentioned.
The freezing and thawing.
Right. When the temperature drops below freezing, the water trapped inside those microscopic straws expands by about 9%.
Oh, wow. So it's essentially acting like millions of microscopic wedges, just freezing and expanding inside the wood grain.
Yes. It creates microscopic fractures in the cellular walls of the wood. Then it thaws, leaving a slightly larger gap, which fills with even more water the next time it rains.
So it just gets worse and worse.
It is a slow mechanical wedging process.
Yeah.
And over time, those expanding microfractures become entry points for biology. Fungal spores that are, always present in the air, find that perfectly damp, fractured environment.
And they just move in.
They do, and they begin to literally digest the lignin, which is the natural glue holding the wood together. That is how you get deep structural rot inside a beam that might look completely fine on the surface.
That is terrifying. And it isn't just the wood losing its integrity either. The fasteners, the metal screws, the bolts, the steel joist hangers holding all this heavy lumber together, they're undergoing their own chemical attacks.
Oh, the fasteners are arguably the most critical vulnerability.
Because of rust.
Exactly. When you combine constant moisture with temperature swings, you accelerate the electrochemical process of oxidation. We just call it rust. But what's actually happening is that the water acts as an electrolyte.
Okay, so it's a chemical reaction.
Yes, facilitating the transfer of electrons from the iron in the steel to the oxygen in the air. The solid, high-tensile steel literally converts into brittle iron oxide.
And it just flakes away.
Layer by layer. So what starts as invisible, microscopic moisture accumulation slowly turns into undeniable macroscopic structural degradation.
And because that microscopic damage is invisible at first, we really need a reliable way to spot it before the structure reaches a breaking point.
That's the key.
And there is a very specific sequence of red flags that tell you this environmental stress test is actively failing.
Recognizing those physical symptoms before the structure yields to gravity is the absolute core of deck safety.
Right, so if you walk out onto your deck, the immediate tactile warning signs are soft or spongy surfaces under foot, or maybe boards that bounce or sag when you step on them.
Or loose or wobbly railings. That's a big one.
Visually, you're looking for water that pools in one spot hours after a rainstorm, any visible cracks in the vinyl surface, rusted metal fasteners, and of course, obvious mold or rot. But I want to be clear here. We aren't talking about cosmetics.
That is a crucial distinction. We need to draw a hard line between aesthetic wear and tear and actual structural failure.
Like peeling paint.
Exactly. Peeling paint or a faded stain might look terrible, but they don't mean the deck is going to fall down. However, the signs we are talking about, like a spongy step or a railing that gives an inch when you lean on it,
That's bad news.
yes, those indicate the core skeleton of the structure is actively crumbling.
Right. A faded deck is a weekend painting project. A bouncy board means the heavy structural joist underneath it might be completely hollowed out by that fungal rot you described.
Precisely.
And the worst-case scenario of ignoring these signs is terrifying. We're talking about sudden structural failure, severe personal injury, and emergency reconstruction bills that can easily hit tens of thousands of dollars.
The mechanics of how these collapses happen usually trace back to just a few critical failure points.
Like what?
Well, support posts rotting at the base, structural loads exceeding what the weakened framing can handle, or, honestly, the most dangerous of all, the ledger board completely detaching from the building.
Here's where it gets really interesting, because I was trying to visualize the physics of a deck collapse, specifically how a ledger board fails.
It's quite traumatic.
For you listening, the ledger board is the long piece of thick lumber that physically bolts the entire deck to the side of your house. It bears half the weight of the entire structure. Think of it like the primary zipper on a heavily overstuffed suitcase.
That is an incredibly accurate analogy for the sheer forces at play.
Right. All the weight, the heavy wet lumber, the barbecue, the snow in the winter, the dozen people at a summer party, all that tension is pulling outward and downward into midair, pulling away from the house.
Constant outward pressure.
All of it relies on the threads of that one zipper holding tight. If the lag bolts fastening that ledger board corrode, they lose their pull-out strength. If the ledger board itself absorbs water and rots, the wood turns to mush.
It just softens up.
Right, and suddenly the tension becomes too much. The metal bolts just pull straight through the softened wood like a hot knife through butter, and the whole system catastrophically unzips from the house.
It unzips, and the moment it detaches, gravity takes over instantly. A deck collapse doesn't happen slowly over a few hours.
It's immediate.
It happens in a fraction of a second. This is exactly why proactive evaluation is mandatory. You cannot wait for the zipper to start visibly separating.
You have to check the threads holding it together while it's still intact.
Exactly. And we also have to consider capillary action in the support posts.
Capillary action, you mean water traveling upwards.
Exactly. We often think of rain falling down, but water also travels up.
How does that work?
Well, a heavy timber support post resting on a concrete footing will act like a sponge. Concrete is porous and holds moisture. The end grain of the wood post sits on that damp concrete and wicks the water upward through capillary action.
Wait, really? It sucks it up from the bottom?
Yes. And the terrifying part is that the outside of the post dries in the sun and looks completely solid, while the inside is persistently damp and rotting away.
Oh, man.
It's entirely unnoticed until a heavy load is applied and the hollow post literally crushes under the weight.
Okay, so if you are listening to this and you walk outside and spot one of these red flags, maybe a rusted bolt on that ledger board or a bouncy spot on the floor, and you realize your zipper is compromised, panic might set in.
It's a scary realization.
How do professionals actually step in to reverse this kind of deeply embedded damage?
They don't guess, and they definitely don't just start ripping up boards at random. Professional intervention follows a very structured, sequential process. It's almost like a surgical operation.
So they have a system.
Yes, they break the repairs down into 4 interconnected layers.
And they tackle it from the inside out, right? They don't start with the pretty stuff. They start with the skeleton. That first layer is structural repairs.
Right.
This is the heavy lifting, replacing the rotting beams or joists, stabilizing those hollowed out posts, and heavily reinforcing that ledger board connection to the house.
Because you simply cannot put a healthy skin over a failing skeleton. Once the structural framing is mathematically sound and capable of bearing the load, they move to the second layer, which is waterproofing repairs.
To stop the decay.
Exactly. This is all about stopping the mechanism of decay we talked about earlier. It involves replacing the waterproof vinyl membrane, sealing the seams, and entirely repitching the slope of the deck so water drains away rather than pooling.
Then comes the third layer, surface repairs, which is replacing the actual floorboards, maybe upgrading to composite materials, and adding non-slip treatments.
The part you actually see and walk on?
Yeah. And finally, the fourth layer is railing and safety upgrades. This means getting the guardrails up to modern building codes, installing glass or aluminum systems, and utterly upgrading how those railings physically anchor deep into the new structural framing.
And to really grasp how these 4 layers of repair interact in the real world, it's helpful to look at a large-scale example. Consider a typical strata building in North Vancouver.
By strata, we're essentially talking about a multi-unit condominium complex managed by an owners association, right?
Yes, exactly. This specific complex was about 20 to 25 years old.
The residents there were reporting the physical symptoms, like cracked vinyl membranes, guardrails that felt loose when you leaned on them, and water pooling on the balconies for days.
Those were the surface symptoms. But when the structural engineers came in to do their condition assessment, they discovered a cascading failure beneath the surface.
It was worse than it looked.
Much worse. The cracked vinyl had allowed microscopic water infiltration for years. That water soaked into the plywood substrate, rotting it completely. Because the plywood was rotten, the heavy lag bolts holding the railings had nothing solid to bite into, which is why the railings were loose.
That makes total sense.
And because the water was trapped under the vinyl, the structural joists below the plywood were beginning to suffer from fungal rot.
Now, on the waterproofing side of this fix, patching or heat welding damaged vinyl seams is standard practice. But I have to admit, when I first learned about this, I was incredibly skeptical.
Really? Why is that?
Is heat welding a damaged vinyl seam actually a permanent fix? Because if water infiltration is the ultimate enemy here, putting a patch over a seam feels like, I don't know, putting a piece of duct tape over a leaky pipe. It feels like a temporary gamble.
Ah, I see what you mean. But if we connect this to the bigger picture, we have to look closely at the physics of thermoplastic materials.
Okay, thermoplastic.
Right. Heat welding is absolutely not an adhesive patch. It is not tape. When you use glue or adhesive tape, you are relying on a chemical bond that will inevitably degrade when exposed to UV radiation and freezing temperatures.
Right, glue dries out and peel.
Exactly. But vinyl is a thermoplastic. When professionals heat weld a seam, they are using highly controlled hot air to literally melt the 2 overlapping pieces of vinyl together at a molecular level.
Oh, wow. So they aren't just sticking 2 pieces together. They are fusing them into a single monolithic piece of material.
Exactly. The polymer chains intertwine. Once it cools, that seam is often stronger than the surrounding vinyl. It becomes one continuous watertight sheet again.
That changes everything.
It does. And this molecular fusion is foundational to the entire repair. Because water damage is the root cause of every single structural issue we've discussed, professional waterproofing is the absolute first line of defense.
It's basically a chain of dependencies. The molecular waterproofing protects the wood structure, the healthy wood structure supports the surface, and the solid surface securely anchors the heavy guardrails.
Precisely. In that strata complex scenario, they didn't just tighten the loose railings. They tackled the root cause and the hidden damage simultaneously.
A total overhaul.
Yeah, they stripped it down, executed structural reinforcements where the fungal rot had taken hold, installed a brand new heat-welded waterproof membrane, and only then did they install the modern railing upgrades.
By addressing the invisible water infiltration alongside the structural reinforcement, they literally reset the lifespan of those decks for another 3 decades.
Exactly.
Resetting the clock sounds amazing, but I mean, a massive multi-tiered reconstruction project on a 25-year-old building also sounds staggeringly expensive.
It definitely can be.
Which brings us directly to the economics of daily maintenance. How does a property owner avoid footing a catastrophic reconstruction bill like that?
It comes down to understanding the financial logic of upkeep. It is a predictable sliding scale of costs based entirely on your level of proactivity.
Let's look at that scale. At the very bottom, you have the low-cost tier. This is literally just basic deck cleaning, sweeping, and washing, done maybe 2 to 4 times a year.
Simple stuff.
Yeah. Then step up to the moderate cost tier, and you are paying for an annual professional inspection, plus catching minor repairs, like a small heat-welded seam fix, as needed.
Which is still very manageable.
Right. But then there's a massive jump to the higher cost tier, which is completely ripping off and replacing the waterproof membrane every 20 to 30 years.
That's where it hurts the wallet.
And finally, the highest cost is a full structural skeleton rebuild, which happens every 25 to 40 years if the lower tiers are ignored entirely.
The financial strategy is so simple. Spend a tiny amount of time and money in the low and moderate tiers so that you drastically delay or entirely avoid the highest cost tier.
That makes a lot of sense.
And the mechanism for staying in those lower tiers is routine inspection. Residential decks should be thoroughly inspected every 1 to 2 years. For strata, multi-unit, or commercial decks bearing heavier loads, it should absolutely be an annual requirement.
But let's zoom in on that low-cost tier, the daily or weekly basic cleaning. Because if you have a vinyl or Duradex surface, there's some very specific and, frankly, highly counterintuitive rules for maintaining it safely.
Oh, this is exactly where human intuition often causes catastrophic structural damage.
I hope the don'ts make sense. Sweep organic debris like leaves off the deck weekly so they don't trap moisture. Wash the surface with a gentle, non-abrasive soap a few times a year. Rinse it thoroughly, check your seams while you're down there, and clear any pine needles out of your drainage scuppers. Easy.
Very straightforward.
But the don'ts are where it gets intense. No bleach or harsh solvents. No stiff, abrasive scrub brushes. No oil-based cleaners. And perhaps most controversially, no high-pressure washing.
That last rule is incredibly difficult for a lot of well-meaning homeowners to accept.
So what does this all mean? I really have to push back on the pressure washer rule because everyone's first instinct on a sunny Saturday morning in spring is to drag out the gas-powered power washer and blast away all the winter grime.
It is deeply satisfying, I'll give you that.
Right. But the engineering consensus is that improper cleaning dramatically shortens the membrane's lifespan and skyrockets your long-term costs. Honestly, using a 3,000 psi pressure washer on a vinyl deck membrane sounds like trying to exfoliate your face with industrial sandpaper. You aren't just cleaning it, you are aggressively stripping away its natural protection.
This raises an important question about human psychology versus predictive maintenance. Your sandpaper analogy is spot on.
Really?
Yes. To understand why it's so damaging, you have to know what vinyl actually is. In its natural state, polyvinyl chloride, PVC, is rigid. Think of a hard plastic plumbing pipe.
Oh yeah, those are super stiff.
Right. So to turn that rigid plastic into a flexible, rubbery deck membrane that can expand and contract with the weather, manufacturers embed it with molecules called plasticizers, along with UV protectants.
Okay, so the plasticizers are what keep it supple and stop it from cracking in the freezing cold.
Exactly. When you hit that membrane with a high-pressure water jet, or scrub it with harsh bleach, you aren't just removing surface dirt. You are micro-abrading the top layer of the material.
Oh no.
More importantly, you are actively leaching out those chemical plasticizers and UV inhibitors. You are chemically and physically accelerating the aging process.
So it turns back into a pipe.
Basically, it turns this flexible, waterproof skin back into a brittle, rigid plastic that will inevitably crack the next time the temperature drops. Furthermore, that high-pressure water can easily be forced under the edges of the heat-welded seams, mechanically prying them apart.
Wow. So by trying to do a really good job cleaning it with brute force, You are actively destroying the molecular integrity of the waterproofing.
Precisely. We naturally want to do something that feels like hard work. Scrubbing violently with a stiff brush, pouring bleach to instantly kill green algae, or blasting it with a pressure washer, it feels productive.
It feels like you're solving the problem.
But in reality, engaging in that aggressive cleaning guarantees that you will immediately leap out of the low-cost category of basic maintenance and hurl yourself straight into the higher-cost category of premature, multi-thousand-dollar membrane replacement.
So true structural maintenance isn't about elbow grease and brute force at all. It is about gentle consistency, sweeping the leaves off so they don't decompose and trap moisture, using a soft soap a few times a year to preserve those plasticizers,
Exactly.
and scheduling a professional with an expert eye to catch the microscopic invisible failures before the heavy ledger board unzips from your house.
It is the ultimate lesson in working smarter, not harder. Routine, gentle care combined with structural literacy prevents catastrophic macroscopic collapses.
Let's wrap up what we've unpacked today because there is a tremendous amount to take away from this.
There really is.
If you are living in a demanding, moisture-heavy climate like North Vancouver, the environment isn't just weather, it is a relentless structural stress test, constantly searching for a vulnerability. You have to be deeply vigilant, spotting the physical symptoms early, recognizing that a soft board or a rusted lag bolt isn't a cosmetic issue, but a critical failure of the skeleton that can literally save your home from an overstuffed suitcase unzipping.
It saves homes and lives.
And when it comes to keeping those long-term repair costs low, you have to fight your own instincts. Put down the gas-powered pressure washer, trade the high-pressure hose for a simple push broom and some gentle soap, protect the molecular integrity of your weatherproofing, and you will save yourself thousands of dollars and decades of anxiety.
The greatest takeaway here is that knowledge of these invisible forces, the physics, the chemistry, the capillary action, it allows you to take profound control over your environment.
Right, you're not just guessing anymore.
You are no longer crossing your fingers and hoping for the best. By understanding how persistent moisture attacks wood fibers, how metal oxidizes, and how thermoplastic vinyl protects the whole system, you transform unpredictable, terrifying emergencies into highly predictable, incredibly manageable routines.
That is a brilliant way to synthesize all of this. But before we go, there is one final provocative thought I want to leave you with. Something to mull over that builds on the material science we've been discussing today.
Let's hear it.
Given how rapidly climate conditions are shifting on a global scale, with wetter seasons, heavier concentrated rainfall, and far more extreme temperature swings becoming the new baseline everywhere, not just in specific regions like North Vancouver.
Right, it's a global shift.
It makes you wonder, will traditional wood framing and chemical-dependent vinyl membranes even be the standard for outdoor structures in 20 years? Or, as these environmental stress tests become more extreme, are we on the verge of a total fundamental revolution in the material science of how we build the spaces just outside our doors?
That is a fascinating question to consider.
Something to think about the next time you step out onto your deck, lean against the railing, and realize you are standing on a complex, slow-motion battle against the elements. Thank you so much for joining us on this deep dive. Keep asking questions, keep looking beneath the surface, and we